So today our topic is special parallelogram. So I have a parallelogram here, and you know this is a parallelogram because opposite sides are parallel. That's from the definition. And from the theorem, we know that in a parallelogram, the opposite sides are congruent. What else do we know about parallelogram? Yes, sir.
It's the opposite sides are.
Okay, so we just talked about that. Yes. Yes, both the opposite angles are congruent. What else do you know about parallelogram? Yes, sir. Diagonals of parallelograms bisect each other is correct. Now, we're going to then talk about some of these special parallelograms. These are quadrilateral that are parallelograms, but have a little bit, it has a special sort of properties, right, that not all the parallelograms have. Okay, so good, raise your hand next time. Kevin said square is a special type of a parallelogram. Can somebody think of other special? Because square is a parallelogram that happens to be a little bit special, right? Not all parallelograms are square, are they? But square is a parallelogram. John?
Rhombus.
Rhombus is one too. Good. So we got square, rhombus. Rhombus is a parallelogram also. Yes? Rectangle. Good. Are there any others? Yes?
A kite.
Rhombus?
Okay, so we're going to keep that as a rhombus. And yes? Actually, kite has, we don't talk about kite. Okay, anyway, trapezoid. Is trapezoid a parallelogram? Okay, so why not, Pomon? Why do you think trapezoid is not a parallelogram? Right. For a parallelogram, both sides must be parallel. Trapezoid, only one side. One pair of opposite sides are parallel. Okay, exactly one. Okay, so good. So, and why is rectangle a special type of a parallelogram? How does that set apart from regular parallelogram? Why is that special? Samantha?
It has all right angles.
Correct. It has all right angles. What about rhombus? Why is rhombus special parallelogram? Yes, sir. All four sides are congruent. So you know what I did here? I drew underneath the parallelogram. You could actually see that there are two special types of parallelograms, rectangle and a rhombus. And as you can see, rectangles, all angles are 90. Rhombus, all sides are congruent. And we talked about a square, right? And square is a sort of nice, interesting parallelogram because it has a characteristic of rhombus, yeah, both rhombus and the rectangle. And Andrew, what is its characteristic? It's a parallelogram that has what? Congruent sides and not congruent angle. Congruent sides and 90. All the angles being 90, right? What did you say? Okay, good. Okay, so I just want you to understand this diagram because what do you think? The parallelogram is right on top, and then all the three of them are underneath. Yeah, Tony?
Well, because the rhombus, rectangle, and square are all parallel.
Exactly. These are all parallelograms. That's why I wrote them underneath, right? So what about then a rectangle? Is rectangle a parallelogram?
Yes.
Yeah. Is rhombus a parallelogram?
Yes.
Yeah, it's right underneath. What about a square?
Yes.
Yeah. But let me ask you this: is a rectangle a square?
No.
Is rhombus a square?
No.
But what about a square? Is square a rectangle?
Yes.
Just kidding, yes.
Square is a rectangle all the time, right?
Yeah.
Because it has that characteristic. All you need is all angles to be 90, correct?
Yeah.
What about, is square a rhombus?
Yes.
Yes. Yes, right? Because in order to be a rhombus, guess what? You need all four sides to be congruent. Again, all these are what? Parallelogram. So keep that in mind. Keep that in mind. Okay. So then let me give you the formal definitions. Okay. And a lot of you already know what they are. So here's the rectangle, and the way we define rectangle, it is a quadrilateral that has four right angles. Is correct. Four right angles. Very good. Okay. So write that down. A rectangle is a quadrilateral with four right angles. Now, if somebody asked you, why then should a rectangle be a parallelogram? What would you tell them? 2 people. 3. Wait, people still writing. I'm sorry. Go ahead, keep writing. As you write this thing down, think about how you would go about maybe prove or show that rectangle is a parallelogram. Because somebody might say, wait a minute, the definition of a rectangle doesn't mention anything about it being a parallelogram, right? It only says it has 4 right angles. But why should this be a parallelogram? How would you say? Esther? That's correct. Remember, there's a theorem, right, that says if both opposite angles of a quadrilaterals are congruent, then it is a parallelogram. Is that right?
Yes.
Okay. Did you say, yeah, Kevin, did you want to add something?
Or you could say that the 2 lines are perpendicular to the same line, so they're parallel. And
Very good.
The other set, and then they're both parallel, and then you can say that they're parallel.
Correct. You could use the definition of parallelogram by saying if 2 lines are perpendicular to the one line, guess what? These 2 lines are parallel. And then you could say, right, the opposite sides are parallel. Very good. That's good. Yes, sir.
Aren't opposite ends
Uh,
No.
yes, they are. Why?
Because like it can only be 90.
Not only that, it's because why are the opposite side of a rectangle all congruent? And it's not even stated here, but it's sort of obvious why. Yes, Jason. In other words, Tony, it's a parallelogram. We just talked about, right? Rectangle, rhombus, and squares are parallelograms. So all the properties of parallelograms will be true. And of course, the rectangle is a parallelogram, correct? Of course, opposite sides are congruent, right?
But then of course
I know that opposite angles are congruent, but what is it that you want to try to say?
wait, why is it opposite sides up there?
Because we know that rectangle is a parallelogram. I don't have to write all that stuff right now. Right now, I am just defining what a rectangle is. That's the definition of a rectangle. Okay? And the second question I asked is, why is this rectangle a parallelogram? We just answer is because
Opposite angle.
you have the opposite angles congruent. This because all the angles are 90. Of course, opposite angles are congruent. Right? And since we know now that the rectangle is a parallelogram, all the properties and all the theorems that talk about rectangles, it is true for a rectangle. That's important. Does that make sense? Okay, next. We have rhombus. Anybody want to guess how we're going to define a rhombus here? Yachan, what do you think?
A rhombus is a quadrilateral with all 4 sides.
Correct. Rhombus is a quadrilateral with all 4 congruent sides. Now, if somebody asks you why this rhombus is a parallelogram, what would you tell them? Yes, sir. Yeah, so what does that theorem say? You're right. If a quadrilateral has
2 pairs of
opposite congruent sides,
then the quadrilateral is parallel.
yeah, if you have, right, both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. And so, Austin, what do you know about the opposite angles of this rhombus?
Opposite sides.
Opposite angles. We know that opposite sides are congruent because it's a rhombus. We know all 4 of them.
Opposite angle.
Why? Yeah, why do we not say this here? How come it's not stated here? Yeah, they don't have to write everything about these parallelograms, right? But do you understand it is true though? Okay, they don't, right? Does that make sense? Okay, next, square. Let's talk about a square. How do you think we're going to define a square? Samantha? And all 4 angles, very good. So all 4 sides congruent and all 4 angles congruent. Okay, so there's a picture. And for square, there are many ways of saying why this is a parallelogram, isn't that right? Because it has the property of the rhombus and the square all together. Okay, so what's one of them? Yeah, opposite sides are congruent, both of them. Also, opposite angles are congruent. And you could say, like Kevin said, right, if two lines are perpendicular to the same line, then they're parallel. And so you could use the definition of parallelogram and so forth. Any question? Does this make sense? So that's what they have here. Okay. So squares is, right? There are many ways of saying this. Any question? Okay, so Austin, I want you to read this part because this is really important. And I think you asked a similar question about this. Go ahead.
Since rectangles, rhombuses, and squares are parallelograms, they have all the properties of parallelogram. They also have the special properties given in the theorems of the next page. Proofs of these theorems are left as exercises.
Okay, so does that answer your question? You know how? Why don't they say, right, the opposite, right? Both opposite angles are congruent, both opposite sides are congruent. Well, because we know they are parallelogram, right? All these are true. We know that. Okay, but these are special types of parallelogram, and now we're going to talk about some of the theorems about the special parallelogram. Is that okay? All right. Any questions? All right. So I bet you could actually. Let me ask you this: if I have a rectangle, which is a parallelogram, right? If I have a rectangle, what can you tell me about the diagonals of the rectangle? So imagine a rectangle in your head. Actually, you know what? Let's draw one. Okay. I have a rectangle. Oops. Let's show the diagonal. Let's say a rectangle A, B, C, D. Okay. And let's show the diagonals like this. Here. So what can you tell me about the diagonal AC and BD? Oh, so I gotta indicate that it's a rectangle. I gotta do this, right? Sorry. Naomi? Yes, they do, but they bisect each other. That's true. That's because we know that rectangle is a parallelogram. So we sort of knew that already. Does that make sense? So that's nothing new. So how is this then for rectangle? Is there something else you could say other than that they bisect each other? Because we knew that already, because we knew that rectangle is a parallelogram, right? And Naomi, any guess? Okay. Take a look at this picture. If you have a rectangle, right? You see how the diagonals are going to be? Let's say if this length is 10, guess what the other length will be? 10. It's always going to be true. Guess what? The diagonals of rectangles are congruent. Did you guys, right? Know that?
Yeah.
How would you go about showing that, by the way, if you had to? Go ahead, think about it as a group. How would you do that? Who could help us? How can you show that AC is congruent to BD? The diagonals of the rectangles are congruent? All right. Yeah, what do you think, sir? Yeah, you have to show that the two triangles are congruent. Which two triangles do we need? Yes, sir.
ADL and ABL.
AD, oh, it's C.
Oh, I mean C.
Good, ADC and
ABC.
triangle, what?
ADC and ABC.
No, you need ADC and it's B, B, ADC, BC, BC, D. Okay, you need those, okay?
Oh, wait, no.
Oh yeah, you do.
Right?
The bottom is.
Wait, can't we just do
reflection?
ADC and
No.
Okay, so I'm telling you right now that these are the triangles you need. ADC congruent to BCD, because if I could show that these two triangles are congruent, then you are done because HL.
Yeah, you can do HL.
How many people say you could use HL? Raise your hand. How many people say no, you can't? Who would like to? Why not? Somebody tell me. Jonathan, why can we not use HL? No, this is what we want to show or prove. We want to prove this. We want to prove that. Okay. In order to prove that, we're sort of going backwards. In order to prove that, we have to show. Need to show. Need to show. This is true. How would you do this? Yes, sir. Rectangles are parallelogram. Good.
Sides are congruent.
Good. So we know that AD is congruent to
BC.
BC and
And except right.
DC is congruent to AB. Okay. So then what?
And then once you get so
Okay.
it's a right angle,
Mhm.
congruent.
Yeah, it's a right angle right here. This is also a right angle. By what are these two triangles congruent?
SAS.
Would you have to show that?
Yeah.
Yes. Question. We have a question. Okay, go ahead.
So you have to use the theorems that apply to parallelograms.
That's
Can you
right.
Can you just say the theorems, but you have to prove that it's a parallelogram?
Right. So
Like
that's a
if
good
they-
question.
If they give you like rectangle ABCD,
Mhm.
do you have to prove parallelogram ABCD, or is it just assumed?
That's a good question.
Okay, long proof.
Would they give you? Would it be given?
So you should show that it's a parallelogram by saying that because, right, the opposite sides, and so forth. So yes, you need to.
What if it's given?
If it's given, of course you don't need to show. If it's given, you don't need to show. All right. So does that answer your question? So yeah, very good. But do you see why by side angle side the two triangles are congruent? You know, of course, if the two triangles are congruent, AC and BD are the corresponding parts of congruent triangle. Okay. Very good. Let's move on to the next. Okay. So that was yeah. Let me show you the theorem first. There it is. It's very short. As you expected, the diagonals of a rectangles are congruent. All right. Now, what do you guys see up here? Yes, Kevin.
A rhombus.
It's a rhombus. Now, and I also have diagonals of this rhombus, right? So can somebody tell me anything about the diagonals of this rhombus? This rhombus. How about Chris? Any guesses? They are perpendicular is correct. So it turns out that these diagonals are perpendicular. Do you guys remember when we were doing constructions?
Yes.
And we had to, for example, if you had a line, right? And you had to draw a perpendicular line through it or something like that?
Yeah, through a point.
Through a point maybe here, okay? Remember how we did the, we used the arc here and here, and then we used the arc, same length here and here, and here and here? What is this when you drew this thing? Isn't it a rhombus? Right? So when we were doing that construction, it turns out we were using this fact, okay, this theorem. But anyway, so it turns out this is 90. Now, is there way how would you show that? Okay, I want you to think as a group. Go ahead. How would you show that this is 90? Go ahead. I'll wait. Okay. Anybody know what to do for this? Why are these diagonals of a rhombus perpendicular? How would you go about showing this here? How about Grace? Oh, I thought you had your hand up. But Grace, let me give you a hint then. Okay? Grace, is a rhombus a parallelogram? Okay, now, what do you know about the diagonals of a parallelogram? They bisect each other, don't they? So Grace, this diagonal will be congruent to this one right here, wouldn't it? And wouldn't this one be congruent to this? Right? Would you agree? Now, Grace, knowing this, how does this help us to show that these two diagonals are perpendicular? Sorry? Yeah. Yeah, side. These two triangles are congruent. Not only these two, it turns out all four of them are congruent by side. Isn't that right? And if that's true, what do you know about if two lines intersect and if they form congruent adjacent angle? What do you know about that? They are perpendicular. If two, who would like to say this? If two lines intersect. Oh yeah, if two lines, go ahead, you say it. But that's the same thing. Yeah, so that's the same one. If two lines form congruent adjacent angle. How are they going to form congruent adjacent angle? They have to intersect, right? If two lines intersect and form congruent adjacent angles, then what? They are perpendicular, and there you are. Does that make sense? Does that answer the question? Okay, good. So guess what our next theorem is going to say, guys? The diagonals of a the diagonals of the rhombus are perpendicular. Write it down. Okay. Now going back to this, what else can you tell me about? What can you tell me about measure of this angle right here, guys? That is congruent to what is corresponding, right? Corresponding parts of congruent triangles are congruent. So what else is this angle right here? Would you not agree? What about this one is congruent to also? That one. Is this one congruent to this one right here? No, but if this is congruent to the one next to it also?
Then it's angle bisector.
Yeah, because of side, right? So, what else can you tell me about the diagonals? They don't, not only do they form, not only are they perpendicular, they also do what? Bisect the opposite angles like this. Does that make sense? Okay, so guess what our next theorem is? So look at how they say it. This is what they mean by that picture we just showed it to you. Each diagonal of rhombus bisects two angles of the rhombus. Okay, so please understand what this theorem is saying is what we just showed it to you in that picture. Does that make sense? It's because all those small triangles, right, four of those right triangles are congruent. Okay. Each diagonal of a rhombus bisects two angles of the rhombus. So let's review what it just said. So if this is, I don't know, if this is 30 degrees right here, what's this one? What's this one? What's this one? You see how this diagonal bisects each angle right like this? So then if this is 60, what's this one? What's this? And does that make sense? I'm sorry? Yeah, because the four right triangles are small ones, right? They're all congruent. Right? Yeah. Guys, what do you see here? A rectangle, very good. Now, I'm going to draw a I'm going to draw two diagonals here. Okay. What do we know about these two diagonals? They are congruent. You guys remember we just talked about that, right? And they bisect each other. Very good. Why do they bisect? So first, we know that AC. No, one. We know AC is congruent to BD or DB. Okay. And secondly, Kevin said it, because a rectangle is a parallelogram, we know that they, let me call this M, they bisect each other, right? Diagonals bisect each other, right? So therefore, AM is what? Congruent to MC, and we also know that what? But don't we know that AC is congruent to BD? So if they bisect each other, we know this is congruent to this, and also, yeah, they're all congruent. Would you not agree?
Yeah.
Because you know that the diagonals are congruent to start with. So we know that AM congruent to MC. Also, we know that MD is congruent to all these, and then what? PM. Is this easy?
Yes.
Okay, so let me ask you this. Let me just draw this triangle right underneath. ADC. Is that okay? What kind of triangle is this ADC, guys?
Right.
Very good. ADC is a right triangle. And guess what this M is?
Midpoint.
That's the midpoint of AC. We know because AM is congruent to MC. Isn't that how, by definition, midpoint? So what can you tell me about? And then I drew this other. What can you AM is congruent to MC and MD is congruent to itself, right? Would you not agree? I just have this part right here. Right? Do you not agree?
Yes.
Okay, so everybody okay with this? Is there any question? Is this easy? Now let's look at this theorem. Guess what? If this theorem, midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. What is this describing? the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. Anybody see what this is describing? One person see it? Okay, I'll give you time to write. What is this describing? Okay, I'll wait. Okay, what is this describing? Yechan?
Oh, no. I was just asking.
Oh, okay. What were you asking?
No, like,
No, because I think you were right. No, say it.
no, like,
Yeah, this is, you're right. It's the same. This is what I am describing. Look, it says, what does it say here? The midpoint of the,
it's from Rhombus.
I'm sorry, midpoint of the hypotenuse. Do you see my right triangle? Isn't the M the midpoint? They're saying that M is what? Equidistant from the, look, A, well, how many vertices I have? A, D, C. Look, AM is equal to, MC equals to, MD. You see how that is describing the same exact thing I just showed it to you before? And where do you think this comes from?
Theorem.
From the rectangle. Does that make sense? So in order to show, yeah, in order to show this, do you think by drawing these auxiliary lines so that it becomes a rectangle, do you think it might be helpful?
Yes.
Okay. Any question? Do you see what this theorem is saying? So for example, if this distance is right here is 3, if this is 3, guess what this is?
3.
That's all they're saying. Okay. This is always true. Of course, you have to have what kind of triangle? Right triangle. Is that okay? So this is what he's saying. Any question? Now let me ask you something, guys. Let's say that I told you that I have a parallelogram. Okay. Let's say that I have a parallelogram, and one of those, the angles of the parallelogram is 90. What can you tell me about, or what can you conclude about this parallelogram? If I told you that one angle of this parallelogram is 90 degrees, what can you tell me about this parallelogram? Go ahead, think about the group. What do you think? All right. Who thinks they know what to say here? Kevin, what do you think?
Square or a rectangle?
Okay, can you say square? So it's actually a rectangle is correct. Guys, listen, this is important. If an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Okay, if you say square, that is not always true, right?
I know, but it could be.
No, it doesn't say
But-
all the sides.
But Kevin, if I replace this rectangle with square, okay, that would not be true. But I know what you mean, right? It could be a square, you're right? But what I'm saying is, well, square is a special type of rectangle anyway, right? So if by saying rectangle, square is included in there. Does that make sense? You don't have to say that. Okay. So, do you see why this is true? Okay. All right. Okay. Does this make sense? Turns out, guys, the reason why this is true is because what do you know about the opposite sides of a parallelogram? They are congruent, and you get the two triangles congruent. And then, okay. Anyway, okay. Next, what if I have a parallelogram and I told you that the consecutive sides are congruent? What do I mean by consecutive sides? Sides that are right next to it, they're right connected. Jonathan, what do you think? If I told you that I have a parallelogram and then the consecutive sides are congruent, what can you say about this parallelogram? It must be a rhombus is correct. So that's our next theorem. And this is the reason why this is true is because why? Opposite sides of a parallelograms are congruent, right? Both opposite sides are congruent. Therefore, if consecutive sides are congruent, then you have a rhombus. Okay. Any question? And it turns out it is pretty easy to show or prove that these two theorems. Okay. So for the first one, you know that the opposite sides of a parallelograms are congruent. For the second one, you know that the opposite sides of a parallelograms are. Oh wait, the first one you need the opposite angle of parallelograms are congruent, and then the other one sides. Okay. Any question? Does this make sense?
Yeah.
All right. Good.